This is your video on solving equations with variables on both sides, but we call these basic problems because if you look at the left, 7x minus 10 is already completely simplified, and 5x minus 6 on the other side is also. So the first step, at least what I've been telling you guys in class, is that you should look at the two variable terms and decide which one has a smaller coefficient. So 7x and 5x would be the things we're looking at, the terms that we're looking at. And so because 5 is smaller than 7, I'm going to go after the 5x. If it's positive 5x, you need to subtract 5x from both sides. If it had been negative, I would be adding 5x to both sides. But it is positive. Notice when I write those, I put them right underneath the x term so that I don't confuse myself and accidentally combine it with the wrong thing, the wrong term. So 7x minus 5x is 2x. Bring down your minus 10 equals... On the right side, 5x minus 5x, that just turns into 0. And 0 minus 6 is just negative 6. Now we're back to a two-step equation. So what I want to do is isolate the 2x, because then I can divide by 2 and I'm all done. But right now I have a minus 10 with the 2x on that same side. So because it's minus 10, I want to do the opposite and add 10 to both sides. On the left side, negative 10 plus 10 is just 0. So we just have 2x. Negative 6 plus 10 on the right would give us a positive 4. And then what I'm going to do now is just divide by my 2. Remember, 2x means 2 times x. So to undo that multiplication, I need to divide. But I need to make sure I do that on both sides. 2x divided by 2 is just 1x, because 2 divided by 2 is 1. So you can either write 1x or just x. And then 4 divided by 2 is 2. So we have our answer. Now we want to make sure that it makes our equation true, and then we know that we did get the right answer. So I'm going to write my original equation, 7x minus 10 equals 5x minus 6. And so my answer was 2, so I'm going to put 7 times 2 minus 10 on the left, and 5 times 2 minus 6 on the right. Now we are going to use the correct order of operations. Now I know that multiplication comes before subtraction, so on each side I'm going to do that multiplication first. 7 times 2 is 14, and then bring down that minus 10. 5 times 2 is 10, and then bring down your minus 6. So on each side, when I do 14 minus 10, and when I do 10 minus 6, I'm going to get 4 on both sides. So we know that we did our job correctly, because our answer made the equation true. Now, moving on to our second problem, we have both of our x terms actually are negative this time. So if you get confused with negatives, in terms of telling which one's bigger or which one's smaller, it really helps to think about negative temperatures, especially because up here in the North Country, we have a lot of negative temperatures we deal with in the winter. So if you look at it, we have negative 10x and we have a negative 5x. So negative 10 degrees is colder than negative 5 degrees. So we're going to go after the negative 10x because negative 10 is smaller than negative 5. So as I said before, if it's a negative x term, you need to add it to both sides. So I'm going to add 10x to both sides. Over here, negative 10x plus 10x is just 0, and 0 minus 3 is just negative 3. So I'm going to write down my negative 3. Over here, negative 5 plus 10 is positive 5, so we have a positive 5x, and then bring down that plus 12. Now, at this point, it's a two-step equation. Some students are totally comfortable with solving that the way it is. Others are not. So many times we're used to seeing the x term on the left side of our equation, of our equal sign, I should say. So if it bothers you having that 5x on the right side, you can actually swap these two expressions, because if they're equal, they're equal. It doesn't matter which one I write on which side. I just know they're equal, so I can swap them. If you're fine with this and you want to isolate your 5x by subtracting 12 and then divide by the 5, I'm fine with that too. You can leave it on the right side. But again, if it bothers you, just swap those around. So I'm going to swap them. So 5x plus 12 equals negative 3. If you choose not to swap them, you'll still get the same answer as long as you do it correctly. So, like I said, two-step equation, we need to isolate that 5x, but I have a plus 12 hanging out there on that left side. So I'm going to subtract 12 from both sides, and then I'll be able to isolate my 5x. 12 minus 12, as you know, is 0, and 5x plus 0 is just 5x. Negative 3 minus 12 is negative 15. Watch out for those negatives. And then now all I have to do is divide by my 5, and I will have x all by itself. 5x divided by 5 is just 1x, or you can just write x. Negative 15 divided by 5 is negative 3. So we have our answer, and now we need to make sure that it really makes our equation true. So I'm going to do that by writing the original equation. So negative 10x minus 3 equals negative 5x plus 12. And then I'm going to put my answer in both sides where I have an x. So over here I should have negative 10 times negative 3 minus 3. And then negative 5 times negative 3 plus 12. So again, we're back to using the correct order of operations. So we're going to do multiplication before subtraction on the left. So negative 10 times negative 3, careful, is a positive 30. Bring down that minus 3. On the right side, I'm going to multiply before I add. So we have negative 5 times negative 3, which is positive 15. Bring down my plus 12. And then on both sides, when I do that last step, I'm going to get 27. So again, we know we did our job correctly because we got the same answer on both sides. It made our equation true.